So today's plan is first we're going to implement more model from chapter 5. And we're going to implement that equipment replacement problem. Okay, so that's the one that we talked about last week. We formulated the math model, and now we're going to implement in Excel. Okay, that's a plan. And if we have time, we'll implement this general flow model. We'll see how long does it takes for us to implement the first equipment replacement model. And we also need to do the case study 4.2 presentation. We'll do that after the break. And then I want to talk about the first half of chapter 7. Okay, and the things from the survey I did on the course Moodle site, like the majority of people think we're going a little too fast, so I'm slowing down a little bit. And so this week it's kind of like we spend a little more time on the modeling part for chapter 5, and we'll continue chapter 7 next week. Okay, so if you have the data you downloaded from the course Moodle site from last time, you can open this. Otherwise, you can go back to last week. Which is here. So week 6, download this week 6 chapter 5 data again. Okay. Oops. Do you have it open? Okay, so first let me ask you, the first formula that we learned last week, here, this VLOOKUP function, what does it do? You guys remember?
It takes a row of some lookup table and someone defined in the lookup table and then selects something kind of next to it, depending on how you set it up. Like, I don't know if that's the easiest way to explain it.
Okay, something next to it. Okay. Okay, so this function is a useful function that returns a value in a table based on if a value in that table matches a value that you are looking for, right? And if it finds the value that you are looking for, it returns the value in the matching row and in the designated column. And that's the third value here. Like if it's 2, then it returns the second column. If it's 3, it returns the value in the third column in the matching row. Okay, and we use this VLOOKUP function to return those node names. So it's very convenient. We only need to write down those node numbers here and use this VLOOKUP function to look up from this kind of like index table to return the city name. Okay, so that's one function we used. You guys remember what's the other function that we introduced last week? SUMIF function. Okay, the SUMIF function, we use that to sum the decision variables that are the inflows to a node, depending on whether that decision variable serves as a flow to a certain node, right? So in the SUMIF function, if we are looking to sum the inflows to a node, then we check to see if the node value here is in this column. That's the 2 node. And if it matches, then we sum the corresponding value in the decision variables column. Okay, and if we are summing up, well, if we want to get the sum of all the outflows, then we look at the from node. Okay, so we'll get to you this more today. Okay, and here, so let's just look at problem 5.3, which is the one that we formulated last time. Okay, so this equipment replacement problem that we formulated last time. If you still have the mathematical model that you wrote in class last time, you can take it out for your reference. Okay, in that model, we created this network to represent the 5-year planning time horizon. for just the first contract. Okay, and remember that what we did is we put the equipment purchasing price on those nodes. So all those nodes represent the beginning of the year. And at the very beginning of the year, if we go through the node, that means we're going to purchase a new equipment. And then we put the price there. And on those arcs, we put the trading value, the trading credit. Okay, so let's just formulate this in Excel. You guys still remember that problem? The equipment replacement problem. Okay, so here I only have had this these data here. So we just copy and paste. Here. So that's the first contract. Actually, we should put the second contract here too. We'll worry about it later. Okay, so this is the first contract. Okay. Now we know that the difficult parts or the time that's the part that's the most time consuming is to calculate those costs that we can use in your objective function. Okay, so before we do anything, we need to calculate the cost. Okay, and the cost include equipment purchasing cost and the trade-in values, right? Okay, so let's just formulate it here, and we'll so what we know is that here, like every network problem, we're going to put those node and arcs, the from and the to possible passes in the Excel. Okay, so we have from node 1 to 5, and we can go from node 1 to 2, 1 to 3, 2 to 3, 2 to 4, 3 to 4, 3 to 5, and 4 to 5. Okay, so what we're going to do will be to put those node number here. Okay, just like what we did here in in those early problems. So we'll put a table like this, the from to. Okay. Okay, so we have from node. So we have from 1, and this is the 2 node. 1 to 2, 1 to 3. We have 2 to 3, 2 to 4, 3 to 4, 3 to 5, and 4 to 5. So this represents that network we created, all the paths there. Okay, and we know that later we're going to just shade this part as our decision variables to represent whether we take that path or not, we do the trading or not. Okay. Okay, so these are the decision variables. And like every network problem, the constraint will be for all the nodes. That's node 1, 2, 3, 4, 5. We will have inflows minus outflows equal to supply or demand, because we kind of like transferred this problem into a shortest path problem. You guys remember that? It's kind of saying we have this one equipment, and at the beginning of the first year, we want to carry it all the way through to the end of the 5th year. And in between, we have to trade it in. Okay, so we always have just one equipment that goes through the entire network from the beginning of year 1 to the beginning of year 5. Okay, so here, later we'll have net flow. Supply or demand. -1 here and 1 here. 0, 0, 0 here. Okay, so we'll take care of those easy part first. So we have the decision variables, and now we will need the constraints. Usually we define the objective function before the constraint, but in this case, it's the constraint part is easier, so we'll do this part first. Okay, so here I'll ask you guys to fill in this part, the net flow. I'll ask you to do it first. So use that sum function. So this should be equals to be the inflows minus the outflows. Okay, and so you calculate the inflows using the sum function, and also the outflows, the sum function. Okay, so I'll give some time to fill this part first. Okay. So if you look at the formula, it says sum if, look at the range first, compare the range with the criteria. And if a match happens, you define which range you sum in the matching rows, right? Okay, so sum. And the range that we're looking at is, first we need the inflows. Inflows, we just said, we need to look at the 2 nodes. Okay. If any value in these 2 nodes matches the value here in this node number, then you sum your decision variables in the matching rows. Okay, so sum if any value in this blue bordered table matches the value that which is the node number, then you sum the decision variable part. Okay, and I want to copy this formula all the way down, so I'm going to put function for, which will be the adding the dollar signs before the row number and column number. So later when I copy this function to other places, these 2 tables will be fixed. Okay. And here, this is only the inflows. Since we combine the net inflows and outflows into just one column, calling the net flow, so we're going to subtract, okay, another sum function. Now we're going to subtract the outflows. So the range that we're going to look at is the from range. So if any value in this range, which is the from, match the value here, again, still the node that we're looking for, then we're going to sum the decision variables in the matching row. Okay, so you can see the formula in these 2 sum functions are exactly the same, except one look at the 2 nodes numbers, one look at the other look at the from nodes numbers. Okay, and then I want to put dollar sign before this. Okay, so that's the function that we use to calculate the net flow. Okay, then just copy it all the way down. Check. Okay. Done. Okay. So this takes care of the constraint. You see, the constraint is really simple when we translate this problem into a network flow problem, right? Okay. Now, let's look at the objective function. The objective function is to minimize the total cost. Okay. And we know that on each node, there will be a purchasing cost. And on each arc, there will be a credit. Okay. Maybe let me ask you, in the shortest path problem that we formulated last time, the shortest path problem, what's the objective function when it's implemented in solver, in Excel? Oops. What's that? So what's the objective function in this problem? Minimizing what? Minimizing the total driving time. And how do you calculate that? Some product of this column, the driving time, and the decision variables, right? Okay, good. Now, if we come here, it should take the same format, right? There should be a cost that's associated on this to here. Okay, so from this 1 to 2, that means we're treating the equipment at the beginning of the second year. Okay, so there will be a trading value that happens and also a new equipment purchasing cost that happens. Okay, and when we formulated the problem mathematically, we put the trading credit on the arc and the equipment purchase cost on the node. But when we put but when we write that, when we wrote that objective function, we did have both values combined, right? To calculate to be the coefficient of that x1, 2. Okay, so here, what we're going to do is to calculate the total cost that happens on each of the arcs. Okay, and since that's a little complex, I'm going to move this a little bit further away. Okay, and here I will have first equipment, or I'll just say cost. Equipment still I have, because we have a net cost. Okay, so equipment purchasing cost. Okay, then the second part we should have the trade-in credit. Okay, then here we will have net cost. And what we're trying to do will be to minimize the sum product of this column, which is the net cost, and with our decision variables, representing the total cost that's going to happen when we use this contract. Okay. I just cut it and put it here. Okay. Okay, so now, last time when we formulated that model mathematically, we've already calculated everything. Okay, you can copy from there. But suppose we just start from this Excel. Okay. We don't look at the value that we created last time. Let's see. Okay, so can we write a formula here and here so that the formula can be copied all the way down? Meaning we don't have to do a single calculation every time for each of those arcs. Okay, look at this one. Okay, I need you guys to think and answer the question. What does the equipment purchasing cost depend on? Okay, initial cost, which is given here. Okay, and annual interest rate. Okay, and how do I know whether it should be this cost times 1.06% or 106% or 106% square, or whether it's 106% the third power or the fourth power? How do I know that? Okay, okay, on the right track based on the node number. On which node number? 2 node. Okay, based on the 2 node number, right? So here, for example, we have a 2 here. What does that represent? We are purchasing it at the beginning of the second year, right? And so what's the cost at that time? It's 62,000 times what? 106. Okay, so the number of power raised is, what's the relationship to the number of power raised to this node number? Node number minus 1, great. Okay, so we can put a formula here. So this equals to be this number here times one plus this annual increasing rate raised to the power that equals to be this 2 node number minus 1. Okay, so with this, when we copy this formula all the way down, say in the 5th year, then it will be raised to the 4th power. Okay, because we're purchasing in the 5th year, and the annual increase, it increased 4 times already. Okay, and these 2 values, this green bordered one and this blue bordered one, I want to fix them, because when I copy this formula down, I don't want these 2 numbers to shift. Okay, so I'm going to put a $sign before this row number here. Okay, and another $sign before this row number here. Okay, and I do want this 2 node number to shift. Okay, everyone get this? I'll wait for you to finish. Okay. Okay, then we can copy this formula all the way down. Okay, so if you check this one, it's raised to the 5th minus 1, 5 minus 1 power. Okay, so these are the equipment cost. I just use just 2 decimal points. Here, this one actually need to be, this should be a comma, it's 62,000, okay. But we use 1,000 as the unit. Okay, now let's look at the trade-in credit. Using the similar logic, let's think about the trade-in credit. Which factors are the trade-in credit depend on? What factors determine this trade-in credit?
Purchase price, and whether it's a 2-year or 1-year trade.
Okay, the purchasing price, right? Okay, so, and whether it's 1 year or 2 year trading. Okay, so the purchasing price, where should we look at that? Is it the same with this purchasing price here? No, it's not this, right? Why is it? Why is this 62,000? Zucker, why?
Because it's based on the initial cost.
Okay, not the initial cost, based on the cost that this equipment is purchased at, right? For example, if I ask you, okay, here, what's the purchasing cost for equipment that we're going to trade in here? What's that? Yeah, I'm asking like here. So what's the purchasing cost that we need to use to calculate this trading credit?
9.66.
Which one?
65.72. That's one we
No,
provided.
69.66.
This one.
No, the next one.
This one.
This one.
Okay, why?
Because it's based on the previous cost, right? I mean, it's like each time, each year, it will be based on the previous year.
Which one is it? Caleb and who says 65.72? Okay. Who says 69.66? What about the rest?
It depends on which one you use, right?
Depends what?
Trade-in credit could be 15%.
No, we're talking about the percentage yet. That percentage is a percentage of the purchasing cost, right? Now we're looking at the purchasing cost. So this trading credit equals to be purchasing cost times that either 15% or the 60%, right? That's the formula that we want to put here, right? Now I'm asking, which purchasing cost is it? We have so many different purchasing costs. Is that this one or this one, this one, this one, this one? Which one is it?
Previous one.
So maybe I'll. Good. Okay, so Shifa just said it's from the node 2. Okay. From node 2, what does that mean? From node 2, this equipment was purchased at the beginning of the second year. Okay. Then, what's the purchasing price at that time? It's this value here, right? It should be the 65.72. Okay, so, and Shifa just hit on the important point. To determine this purchasing cost, we need to look at this from node number. Okay, like here, this column, this equipment purchasing cost is, we look at the 2 number because we are thinking about what's the current purchasing cost. Okay, but to determine the trading credit, we need to look at, okay, what's the price this equipment was purchased at? And that is determined by this from node. The from node here means equipment purchased at the beginning of this certain year was trading, is to be trading right now. Okay, is it clear now? Okay, so for this purchasing cost here, I'll leave this, I don't know whether it will accept, no, okay. Okay, so if I just, but you guys remember this formula here, right? Okay, I'll just delete this. Okay, so here, back to here, equals to be the purchasing cost. So there are 2 different ways. Or maybe I'll let you think about what do you think? How do we put this formula here? So we know that it's determined by the from node, right? Okay. VLOOKUP. Okay. And where do you, yeah, think about again. Where do you look up that?
We look up from in the we look up the from node in the to node, and if they match, so take the purchasing cost.
Okay. Okay. That's one way. Okay, that's one way. Yeah. But the problem is that for this one here, we don't have a 2 node 2 year one, right? So basically, like for example, the purchasing cost here, we have to refer to this cost here. So what Shima suggested is that because what we just talked about, for example, if we go back to look at this formula here, what Shima suggests is we use the VLOOKUP function to see, okay, if it's from this 2 node, then we look at this value in this 2 column, right? If a match happens, then we return this value here. Okay, I'll put this here just to illustrate. So VLOOKUP. So we're going to look up this value here. This because we said this from node number determines the price. Okay, and we calculated the price in this column here, right? We look up this value in this table, and if a match happens, which means in those two values, if a match happens, we return the value in the second column. Okay, so this is a good way to practice that VLOOKUP function. Does that make sense to you? We look up this from node value in this entire table. If a match happens, see here, we found the 2, then should return 65.72. See if it works. Okay, so it works. Okay, but the problem with this is that when we copy this formula here, what happens? We got 2 non-applicable, right? Because when we look up this 1 value in this table, there is no matching value here. But we need this 62 here. Okay. Okay, so we suggest, okay, if it's equal to 1, then return 62. Okay, that's one way. Anyway, this is one way, and if we use the if statement, we'll make it work. Okay, so this is one way. What's the other way? Don't make it complicated. Think about how we calculate this equipment cost here. We use this 2 node to calculate the number that this purchasing price need to, the interest plus the 100% need to raise to the power. Here, the trading value, we just say, okay, in this column, the 2 node number determines the number of power I need to raise. Then here, just the from node number determines that, right? Can we just copy that formula here? Let me copy this formula here. Oh, I should have fixed it. Okay, so I'll just move this back, and we're going to use this from node. Okay, just now when we calculate this purchasing cost, we use this 2 node to determine how many the power this rate need to raise. Now we just use the from node, right? And if we do that, we run into no problem. Okay, so we just get these, and you can see it's the same. We got the same thing. Okay, so that's the equipment purchasing price. Okay, and I'll let you finish this part first, but we're not done yet. I'm going to put this in bracket to represent that's the equipment purchase price. And just now we said we need to multiply that, whether it's 60% or it's 15%. Actually, I should do it here. Oh. Okay, here. I'll put this equipment purchasing cost in bracket. Okay, and now we know that we're going to multiply either this 15% or this 60%. So what does what determines that? What determines if it's 60%?
The difference between 2 to 1?
Good. The difference between the from node and the to node, right? Okay, if the difference is 1, then we go with the 60%, right? If it's 2, then we go with 15%. Okay, now here we're going to use the if statement. Okay, so times if. Okay, so the logical test. If this number minus this number equals to be 1. then we return this value here. Because there are only two choices, 15% or 60%, right? Otherwise, return this one. And I want to fix these two. I just fix the row number should be good. Yeah. So I'll put the $sign before the row number here. The name. Oh, I need. Okay. Oh, right. This is in Excel. I just use another parenthesis. Okay. Okay, now it works. Let's just copy this all the way down. We'll just click on this to see. Maybe let's just do a very quick hand calculation. So this is from year 4 to 5, so it should equal to be the equipment that you purchased in year 4, so which is this value. So that's this value. Multiply, it's a 1 year trading, so multiply 60%. Okay, so I just did a test for this last value here. Okay, I just used this value, the equipment purchasing, because it's year 4 to 5. So I use the purchasing cost from the year 4. Multiply, it's a 1 year trading, so this 60% to see if it matches. Okay, because we copy like those formulas and want to make sure it's copied correctly and we calculate it correctly. So this is one way to check to see whether you enter this formula correctly. Okay, I recommend you do this in the cases and maybe even in the homework, especially in those complex cases, because you guys all have some experience now. Having one small error in your model takes a long time for you to figure out the solution later. Okay, so we're trying to be error-free when you enter the data and when you enter the formula. Okay. So with that, we can calculate the net cost. So net cost will just equal to be purchasing cost. Subtract the credit. Okay. And so we're going to copy this all the way down. Now we can have the objective function, which is total cost, equals to be the sum product of the decision variables and your net cost. Okay. We're going to highlight this in blue, representing it's the objective function. Okay. And then go to solver. Our objective is to minimize this total cost here. Okay. Variables are those yellow shaded ones. Constraints. all the net flows need to be equals to the supply or demand here. Make them non-negative. Make sure you use the right algorithm. Click solve. Okay. Always read this message here. Okay. So we find the solution, all constraint and optimal conditions satisfied. Okay, that means good. We find the optimal solution. Okay. And you see that all the decision variables turned out to be integer. 10 value. Okay, and we have the option to create the sensitivity analysis report, which is again the benefit that I mentioned earlier, to have a balance of flow rule constraints, which are these ones: net flow equals to both supply or demand, and integer right hand side. So integer right hand side of the constraint 0, 1. Okay, so and we find the total cost, minimize total cost. And so in this way, what we are saying is that, okay, suggestion to trade in the equipment in what? In years 2 to 3, right? 1 to 2, 2, oh sorry, in years 3. No, actually we're trading every year, right? You guys see? From the solution here, what's the trading plan? We're going to use it from 1 to 2, and trading 2 to 3, then 3 to 4, and 4 to 5. We're using that 1 year trading for all the 5 years. So here, suggestion in every year. Okay. Now, we're not done yet because this is only the first contract. Okay. Are you guys done with this one? If you are done, then I don't know whether you know how to copy this cell. Okay. Right click on the cell, click on this move or copy. Okay. And then click on create a copy. Move to end, click. Okay. Then you have this entire sheet copied here. And the advantage of copying this entire sheet, instead of say like instead of like highlight this part and copy and paste to a new sheet, copying an entire sheet gives you all the solver set up, copied. Okay, so that's one advantage of copy this entire sheet. And in this case, because we know that what we want, the changes in the second contract, so I'll just change this as contract 2. Okay, the changes in the contract will be, okay, price increase 2% each year, 30% and 10% trading. Okay, so let's just change this one. This is a 3%. And here 30% and 10%. You just change all those values. And go to solver. Ask solver to solve it again. Done. Okay. So the cost here, and in this case, the suggestion is to trading from year 1 to, so at the beginning of year 3 and 5. So that's what? A 2-year trading. 2-year trading and the 2-year trading here. So that's to go this way. So 1 to 3 and 3 to 5. Okay. So this suggestion is to trading the equipment every 2 years. Okay. And then you compare the cost. So the total cost using this second contract and trading every 2 years is 122,000. Okay. Here, this first contract in the optimal path, trading every year is $124,760. Okay, so what does that mean? Okay, so the overall using the second contract and the trade in the equipment every 2 years is optimal. So our suggestion to this company would be, okay, you should sign that second contract and trade in the equipment every 2 years. Okay, so with this example, we demonstrate again why we want our models created in a way that it can be copied easily and modified easily. See, like in this case, we just we copy this entire sheet and just change those values and resolve it again. And then we have the optimal solution and the objective function value in the optimal plan. And we compare them, then we got the optimal solution, the overall optimal solution. Okay, so this is the equipment replacement problem. So I'll put this contract 1. And we have the overall answer to this question here.